Yeah, so this is a program we've been working on for a while. I came to Arlington from the private side, design and construction previously. Been here for 11 years, and water resources has kind of been my niche, my focus, stormwater and water resources. So when the opportunity came to try and, well, not try, but be required to start focusing on water quality improvements in the Mystic River watershed, I started with these just trenches, and this is basically going to be just a quick summary of how it's developed. So let's start by saying, I would have to say 8 years ago, I can't be for sure, but we had a tanker truck spill on Route 60. They had a 10,000 gallon diesel on the back. It tipped over onto a fire hydrant and dumped into a catch basin that was about 150 feet away from the Mystic River. Needless to say, it ended up in the Mystic River. So it took about 3 years, but eventually there was a DEP grant available to utilize some of the funds from that fine, and we had a washed out outfall in the area, and we applied for it. And what you see there is what we call the Mystic 35. This is nothing to do with the infiltration, but as part of this project, we needed to do an in-kind submittal to be part of the grant. So we proposed to do some water quality treatment in the watershed area and we were going to start by just putting a water quality treatment unit, maybe a baffle tank or a Vortechnics unit somewhere. And you'll see on the screen, outfall 57 is right where that previous picture was. So when we started looking a little more closely, initially it was just conceptual. It's like, oh yeah, this is great. We'll throw something in the street, right up gradient from that outfall. And it turns out that it's not always so easy because the streets are crowded, and we had MWA infrastructure, we had water, sewer, gas. So all of a sudden our BMP wasn't going to fit there. So I dropped back to punt a little bit, and I contacted a local contractor. And my thought was to convert some catch basins to leaching catch basins in the vicinity. And I brought him out there, and he said, Wayne, why do you want to do this? So he was really candid with me, because this was the start of this program. I said, well, we'll remove this catch basin and we'll get some infiltration in there. And we do it at a couple different locations. And what turned out is, if we were to do this work here, we would have had curb removal, we would have had sidewalk removal, we would have had needs to stabilize this particular utility pole. And by the time we put back the infiltration trench, we would have spent more money on the removal and replacement of the existing infrastructure than we did on the BMP that's actually going to infiltrate the water. So we came up with an idea to stay away from the larger impacts that have like a 5 or 6 or 7 or 8 foot diameter excavation, and we decided to go with something small. So we came up with a program that has a lot to do with site selection, but tried to put infiltration trenches in the street, 2 feet wide, whatever the length required, so that we are in the right of way. The only thing we're going to have to R&R is the asphalt trench patch. So we found out along the way that this gives you a very small footprint, and you can see here some of the pictures. It's really a pretty quick and small impact when we're done. So it's kind of a process when everything shows up to build it. The streets are busy and blocked, but it's really simple. And here's just one small one that's coming off of the existing catch basin. And what we did is we did a preliminary survey of catch basins in the area, identifying catch basins that have a relatively shallow outlet. And our goal was to install these trenches so that the outlet to the trench was 3 inches below the existing outlet to the main drain system. So this is basically the water will rise up, go into the infiltration trench, hopefully store the volume and infiltrate. If the capacity is exceeding, it keeps on coming up. It eventually goes back into the main drain. Let me preface this is that obviously you need some good soil conditions. So we obviously, as part of the site selection, we looked at the web soil survey and identified soils that were in the hydrological soil group A. You could do B soils as well, but you wouldn't have the phosphorus removal as high as it is in the infiltrated soils. So in developing this construction process, we tried to keep it simple, so there'd be no expensive proprietary products. Hopefully you get most of the parts from your local irrigation supply provider or your pipe dealer here. In addition, we also worked with the UNH Stormwater Center, and Jamie Houle from the center developed a spreadsheet for us to enter the data, develop tributary area, class evaluation, land use evaluation, so we could easily plug in the very simple criteria: length, width, soil type, land use, and it would spit out a pollutant removal at the end of the spreadsheet. So we could identify how much pollutant removal is coming from this trench per year. As part of that, I'm going to get back to the construction part of it. The good part of this program is it's small. We can't really specify means and methods to contractors, but over the 2 years that we did it prior, we developed a recommendation of suggestions that we found successful, which was to install the trenches, keep them small, allow them to keep the barrels there for the week until about Thursday. We found they could install about 2 trenches a day. This allowed them to continue on with the construction, do installations from Monday to Thursday, and on Friday they could just focus on paving and closing up for the weekend. What that allows is, as opposed to paving them every day you might have 8 tons that go down on, or maybe 6, go down if you were to pave it every day. But that truck now has to travel and get a small amount of asphalt every single day. So an hour there, an hour back, 2 hours a day, 5 days, 10 hours. If you wait till the end of the week, you'll still get a truckload. It'll just be larger, still fits in a truck, and they'll be able to get all of those 8 or 10 trenches paved on a Friday. Kind of want them to stay on site. Basically, just keeping this efficient and trying to give them recommendations that this how we feel the best way to install these efficiently. It also focuses on having one truck there in the morning. They excavate the material into the truck. The stone has already been placed either in another truck or to the side, so that we recommend they discharge directly into a truck, so you're not spending the extra effort to load and unload and have to clean up the street after. So material management is really something that if you can not have 2 guys cleaning up at the end of the day for an hour sweeping, you got 2 more hours that you could have done putting into the actual trench into the ground. So it really was trying to give the contractor enough tools to do their job quickly, efficiently, save money. If that works for them, we'll get a lower price on the bid. So that's how we developed. Another thing we have to deal with here, obviously, is the butters. We worked with the Watershed Association as part of the grant, and they took part by putting out web notices, handing out door flyers. We used them to do things that they were best at, which was to get out and do some outreach and notifications and kind of show and tell to the community for what we were doing. And then that's what it looks like when we're done. It's we obviously wouldn't be doing these on brand new streets, but as long as they perform the work and we're monitored properly, the design they install as designed. We've had I think only one trench in the last 3 years that had a little dip in it. So it's important to make sure you monitor, make sure they follow the particular guidelines for installation. One of the other efficiencies that we use here is we did not use a compacted dense grade material underneath the pavement to minimize trucking. We developed it so that the stone trench is actually up to the bottom of
please.
So one less truck going to get dense grade, one truck just to get stone. So one more step removed from the process, again, to try to make this efficient and cost effective. First trench that we did turned out to be about $2,500 a day. The contractor realized in the end he didn't lose money, but he said that was probably not going to last. And the next year we did it, it was up to about $3,500. And before you ask about phosphorus removal, we're still working on coming up with a table showing the phosphorus removal for all of these. And the third year, the third year was even higher than the 35. I think it was about $3,750. So the prices are still pretty good for cost per pound removal of phosphorus, which was our concern along the Mystic. We just haven't officially documented it enough for me to throw it onto this slide. So I'll just say it's a work in progress. And there's my mouse, it lost its here. So this is a little image showing the trench from a design point of view. On the right side with those tables is the stormwater centers from UNH spreadsheet that you enter the data in each column with the brown beige color is 1 BMP. So we had 11 that year, the first year. And you only enter the data into the colored cells. And then down the bottom, you can't really see it very well, but that gives you your contaminant removal for phosphorus, nitrogen, volume, and TSS removal also. We were really doing this to focus on phosphorus. And the detail on the left shows really just the outlet pipe to the trench. More important, just keep a 3-foot offset from the outlet pipe. So a pre-survey of the area where you want to go, you want to develop or locate a trench. You don't want a catch basin that has an existing outlet. We kind of figured about 3.5 feet. You don't want to be lower than that because you start losing the ability of not cost effective, effective volume storage within the stone. One of the other things we were working on for the cost efficiency is we came up with 2 approaches to, again, minimize extra efforts of the contractor. So try to minimize the trenches, keep them at 5 feet, where there's no requirement for a trench box. So one more truck with a trench box on the trailer, moving it in, unloading it. Again, more work, less time putting a BMP in the ground. So we kind of try to stay above 36, 42 inches at the very lowest for existing outlet pipes. And that way, when you dig down to a 5-foot depth or possibly 6-foot depth, but we stipulate that no one may enter the trench until stone has been placed to bring it back up to that OSHA 5-foot level. So trying to keep it so there's just less steps involved. And depending on the height of that pipe dictates how much stone you can have underneath it. The more volume you have underneath it, the more P removal you'll have from the spreadsheet. The first year we did this all by ourselves. The second year we did it by ourselves as part of the DEP grant. Second year, we did it by ourselves with the coastal zone management grant. We worked with the Watershed Association to get through the grant, finalize the details, and kind of make this a cookie cutter approach to the program. And then through our discussions through our MVP program, we started working with Mystic River Watershed Association, branching out and saying, okay, we're going to go outside of Arlington. And the next year we worked with Lexington. This year we're working with Medford and Winchester, and the goal is to have a watershed-wide approach. So this process can be used in multiple different towns with little effort, just following the cookie cutter recipe here. So the trench goals here, as I've been stating throughout the presentation, is we're looking, our most important one was the phosphorus. That's what's giving us our problems with the cyanobacteria and the water quality in the Mystic. But it has some other benefits, the TSS and nitrogen removal and things like that. These are small scale, they're affordable. The nice part of it is every year we got to clean our catch basin anyways. So when we clean our catch basin, we're cleaning prior to the, that's the maintenance you need to redo in order to maintain the trench. The only other part is we provide an observation port in the trench so that you can monitor once a year, do an inspection. You want to check in 24 hours after storm, make sure the infiltration is working and that there's no water within the trench. So it's really pretty simple maintenance wise, as long as you're doing your catch basin cleanings. One inspection a year after a storm, just to confirm that it's working. We found that initially I had used a proprietary hooded outlet. I think it's called the Eliminator. That was kind of expensive. I think it was probably one of the expensive single pieces. It was $250 or something like that. But that allowed an access port to get in and potentially jet and clean out the trench line. So that is one of the original ideas that we had, but not every catch basin can have that in. We learned a lot that as you pay attention to these catch basins, you have flat tops, you have cones. Is it coming in the cone? Is it below the cone? And sometimes the pipes don't fit together. So you got to be careful when you're laying this out. So here's a single version of the trench detail showing the offset pipe installation and the observation well at the end of the trench. There's a surface view of the observation well. And this one here, we had a data logger in there. So UNH is still tracking the data just to see how often it fills up and how long it takes to go back down. We haven't touched base with them lately, but I should, and we'll get some information on the effectiveness of that and if it's changed over 1, 2, or 3 years. So what we learned, I think, as I mentioned to you, is as we're doing these designs or laying them out, we do a pre-survey for the area, and we tried to pick areas that would pose less impact. So we tried to stay away from driveways and intersections. We reviewed available record data for utilities, so we could avoid those. Sometimes the data wasn't available, and so we did a secondary wand to the area with a metal detector in case any of the covers were buried. So we kind of did a thorough pre-survey of each potential location to make sure that we weren't going to encounter something that would make us have to avoid a particular trench that we had already designed. So before we design it, we confirm that there's hopefully nothing in the way. Obviously, sometimes underground you run into things that you don't plan for. But with this, if that happens, then you can make it shallower and longer, wider and longer. You can do different variations to the trench if you're on site and need to change it because of an unforeseen subsurface conditions. This kind of shows where I said we want to try to stay away from the driveways. to keep the impact down on the residents. This is a good example in the middle that shows you the trenches on, say, a Monday or Tuesday or a Wednesday. They're still coned off. There's still access available and material stored to the side. Erosion control required if it's going to rain. And then on Friday, it all gets cleaned up and it all gets paved. And it's in process, you see, it's not that much of an impact on the neighborhood. And this is kind of what we encountered here. You see the trench in the middle. That's the one that we succeeded at. Some of the things you encounter along the way will be a gas main longitudinally going down the street, water lines, water services, drain lines. You can see the paint on the ground. Before you do the design, just understand what's in the area as best you can with some research. In terms of the catch basins where we're going in, I talked about the hooded outlet. The green eliminator was more suited for a flush horizontal, or no, vertical seating on the pipe. And you'll see on these areas here that because of the cone or the construction of this manhole, that wasn't going to work. So we found a couple areas where I'm not sure what we came up with, but that one on the left needed, I'm not sure what they ended up putting on there. It needs something, obviously. Middle option was a T, just a typical T. I'm still coming up with something that you can use to modify standard trenches or not trenches, pipe fittings or elbows. The one on the right is just an elbow. I don't like that particular approach because you'll sometimes get a vacuum block, and as the water rises up, it won't get there. So we talked to our water crew. We brought them out there and showed them what we had, because sometimes this particular one, they might have to clean it out with a Vactor. And they said, as long as we core in like a 3-inch hole, something that they can get their Vactor truck missile into it, something to gain access into that will allow us to maintain it in the future. Still trying to come up with a schematic of a little brilliant idea to not leave the opening so floatables can go into it. But in this area in Arlington, we're very lucky that it's very sandy. So the infiltration worked very well. Only on a large, high intensity, short duration storm do we expect it to go above the capacity of the trench and into the drain line. If you have B soils or not so infiltrative A soils, you may want to put a little siphon extension onto the elbow so that the overflow and the floatables won't go into the trench line. There's our eliminator. So I should have put that first, just because that's what I've been talking about. I like this because it's got a low profile against the wall, gives you more room to get the clamshell in to clean the manhole, and it has the access port with the yellow side outlet. So I'm going to review our first year. Was we had a grant and we needed to do the infiltration trenches as a match, so we put in 11 trenches. The next year we ended up with a $135,000 grant from CZM, and we also put in some rain gardens as part of that, which I think are well suited in certain areas. But the pollutant removal and the cost comparisons, the street trench is definitely more efficient for removal per cost. Second year was last year, or third year was last year. We got $184,000, and that was the one we split with Lexington. So we're getting into this year will be our fourth year of putting infiltration trenches in the ground, and working with the Watershed Association. We're now branching out, so this isn't just an Arlington specific thing. We're getting other towns on board, following the processes, and the trenches we're hoping will become a watershed wide approach. So here's where they're entering. These are all the outlets in the Mystic River Watershed Association. The first year this is one of those time lapse ones. I'm supposed to click on something that's supposed to be operational, but you see the 11 trenches in Arlington, which turned into 25 the next year, and then it turned into 75 when we included in Lexington. After Winchester and Arlington and Medford do it, you'll see that the color code is starting to branch across the watershed. As part of this, the Mystic River Watershed also got a 604B planning grant, and they have a grant to develop 255 trenches in 9 different towns. So it started as a little project in Arlington, putting in 11 trenches. We've revised it, refined it, trying to make it simplified and reproducible. It's starting to branch out, and this is where we want it to be. We want it to be a watershed-wide process, so everybody can use it. And there you go. That's it. Open for questions or discussion.
Yeah, Wayne, could you go back like 5 slides to the plan view, the full screen plan view? There it is. Can you just describe how this works? Because I'm so the water comes in the catch basin.
Can you see my hand? The pointer?
Yeah.
Okay. So obviously the sump is, if it's watertight, which it should be, the water level is going to sit at the lowest outlet, which is going to be, if the trench wasn't there and you just had the outlet pipe on the right, then your water would fill up to right here where that arrow is. And then once a year you clean the catch basin, water comes in down the gutter, flows into the catch basin, flow rises, goes down the pipe. Floatables are filtered out by the hooded outlet, and the heavy sediments and aggregates fall down the bottom. Typical catch basin. What we did was we looked for catch basins with a relatively shallow outlet pipe, and then we installed the infiltration trench 3 inches below it. Provided the same hooded outlet, so as the rain comes down the street, comes through the gutter, falls into the catch basin, rises up, instead of going down the outlet pipe to the river, it's going into the infiltration trench. Like I said, our soils are super, it's like beach sand. Or some of the areas in town are phenomenal, and we have been focusing on that area. So I'm trying to use up those areas, and that's where we try to put them. So you'll have the volume storage of the stone pipe and the high infiltration capacity. So figure, say we get 98, 100 storms a year, probably 90% of them are a long duration, not a very high intensity, anticipating that the majority of all those smaller storms aren't going to go out the pipe to the river. They're going to infiltrate and go into the trench and infiltrate. For those times when you do have a high intensity storm and the inflow exceeds your infiltration capacity or the volume capacity of the infiltration trench, it'll rise up to go into the original outlet, and it'll act just as it did prior to you even putting in the trench.
And that pipe, I see it's corrugated. Does that mean holes throughout it? Yeah. That's
the perforated pipe. We've done 8 inches so far. So water comes in, goes through the orifices, into the stone. The pipe on the end is just a port to the bottom of the stone. So after a storm, say you get a big storm, good to go out and check. If it had come to capacity and filled up with water, 24 to 48 hours later, you want it down again so it's ready to receive the next storm. So I hate the fact that we have to put it in because it's a cost. The pipe's not that expensive, but once you start getting into a cast iron access port and the fittings, you know, it's another, I don't know, $200-400 that I'd rather put into another trench, but we got to be able to inspect it every year, and this is the way we developed so far. Now, on a side note, we found that there are some areas that you can't do this. You'll have a catch basin and there's equipment, or not equipment, pipes in the way. We do have a couple of the details that is really, it's a little more work and a little more expensive, but basically cut out a section of the curb prior to a catch basin, just kind of creating an inlet. And then in that inlet, we used I'm sorry, I don't have the detail. Basically a large irrigation control valve box, 2 of them screwed together up and down, placed behind the new inlet. The inlet has an old snowplow blade, the 1/2 inch by 6 inch, welded together and poured in place just like it's filling the curb. And then the water will go into that inlet prior to the catch basin. Then from inside that inlet, we have a configuration of pipes that just goes into another infiltration trench. But the benefit of that is because it's coming in at the surface, we're not restricted by the depth of the outlet pipe. We can go down with a 3-foot trench. Now we can go over a water line or a sewer line or something like that. So that's how we got past the problems when pipes are in the way. It's more expensive. It's actually kind of cool. I'll try to incorporate some photos into the next slide presentation, but we really haven't completely refined it yet. That inlet chamber, I was trying to use off-the-shelf parts from an irrigation supply house. I'm still working on it, so I don't want to advertise it yet because it still has some tweaking to go. But we've gone through our first round of hiring a contractor come in instead of just doing rain garden repair or maintenance. We've included the 10 trenches that we did do for them to come in and clean out by hand or with a shop vac to clean out these chambers, which have a T configuration with a little atrium grate, stuff that you can pick up at Home Depot that allows the stuff to keep the debris from going into the trench. And it seems to be working well. It's just a connection to from the chamber to the welded iron inlet that I'm trying to work on as well. Sometimes the mortar gets brittle and still working on it, but it works. So that's what you do when you, and we call that a green trench because you can put grass on top of it, use a bioswale, make it a little sandier so you get some surface effect of infiltration, and you also have subsurface infiltration from the street.
Wayne, during this presentation, I was curious, you backfill that entire thing up to the street with washed stone.
Yep.
But most of the washed stone over above the invert of your outlet pipe to your existing storm system never gets to be used because once it gets up 3 inches high, it goes away. Is that for convenience of construction or is it, or what?
Yes. Yeah, that's it. And it's just to try to keep going down that road of less work requires less time. Right. So one less truck to go to get the dense grade. And now a filter fabric, we've gone up and we've just run the stone because the truck's there anyways. And I think there are a couple yards per trench. So you can just, we filled it up, pave right on top of it.
And your existing sump, it just says existing. Is that 2 feet, 4 feet? What's your sump depth?
Whatever you have. Ideally would be our 4-foot sumps. But regardless, if you're following your catch basin cleaning program, you should be cleaning it when it gets 50% full, regardless. I wouldn't do this on a gutter inlet.
Right.
Obviously, you have to be selective in the catch basins that you connect to.
And I'm just wondering if you drop the invert of your perforated pipe another 3 to 6 inches, that gives you that much more capacity because the pipe itself will hold more, for the little rainstorms, without taking too much of your sump weight. So if you're really good at cleaning your basins, which you guys are, then you'll never get more than 18 inches and you'll be in great shape. And I just wonder if you did that, if the capacity wouldn't leap upwards by quite a bit, if you could drop it another 3 inches.
You're assuming we have a good catch basin cleaning program.
Well, everything else you got looks pretty good, so I assumed you had a good clear space and cleaning program.
Well, there's where the subtleties of each town comes in. It's your program now. Once you decide to do it, you can do what you want. But that's a possibility. Right. And honestly, we haven't had enough study. We've only had that one trench that had the data logger in it, and our sand is so permeable. I don't think it's a concern for us, but. It's an option. Even more so if you're up in the 2-foot range rather than the 3-foot range, then dropping it another 5 inches or 6 inches wouldn't really hurt it. So we could try that once. I don't know how we'd monitor or know. I mean, we'd have to know how often these exceed the capacity of the volume storage. And that's, we haven't got to that. I've been trying to work with Jamie from the UNH Stormwater Center. A lot of people, I'm surprised I haven't got the question yet. They want to know, well, how much phosphorus is it removing? Because the spreadsheet has been tweaked a couple times by the center through discussions with EPA, and every time they do it, they keep lowering our P removal. But realistically speaking, 90 storms a year, if they're not exceeding the capacity of the infiltration, all of the first flush is taken care of. I mean, we're not getting credit for that. So I've been talking to Jamie to try to somehow come up with a pilot to do some in situ modeling of what's the phosphorus in and what's the phosphorus out. But he explained, and it's true, there's so many variabilities. Depth of groundwater, so you can have a sand and another sand, and the infiltrations aren't the same. So he basically has dissuaded me from it. But right now, this is really just a recipe for what they think the phosphorus removal is. And if you look at the nomographs that they're using, the ideal removal is on the elbow of the curve of the nomograph. Most of our trenches are a little bit to the left of that. So it's into an area where it doesn't give you a reading on the spreadsheet. So this year is actually the first year where we're going wider, longer, and deeper than I did before in order to hit the nomograph, which I think is wasteful because I still think it's doing the work in a 2 or 3 foot trench rather than a 5 foot trench or a 4 foot trench. It's got extra depth. But yeah, if you can think of a way to magically figure out phosphorus in and phosphorus out, I think you'd find that these are removing more than the spreadsheet is actually telling us.
No, and it probably is. And of course, it depends on the tributary area to that particular basin. If
Right.
one basin has 300,
they're almost all the same. They're almost 250 to 300 feet between catch basins. And we're in a dense town, so basically we enter the tributary area from the lot's frontage, and 70% of it is typically impervious. So yeah, it doesn't change very much. The impervious area
Right.
has a lot of blocks in the east end. But yeah, I wish we could come up with a better way to identify the actual removal rate.
Yep. No, I like the whole system. We built a couple of these out in front of our facility where the trench actually runs underneath the street trees that were constantly dying because we tend to salt the hell out of street trees during the winter to see if we can make them live or not, because we want tough trees in our city. And
Right.
but they seem the first year for 20 years now, this is the first year we actually have trees that look like they're living. And we think it's because we have this plentiful source of water every time it rains out.
Yeah.
The first inch of water gets to sit there. 90% of our storms are 1 inch and less.
Yeah.
And we claim, of course, because we listen to the EPA so well, we claim that all the phosphorus is removed in that first inch because we have great water shots.
Yeah.
Yeah. And I know I argue with Jamie all the time, so it doesn't matter.
Yeah. So just that was a good segue. In addition to our green trench, we developed an add-on detail, which basically changes a little bit, but basically extend the trench without being 3 foot tall. We make it 1 foot tall, throw some fabric in, put a half a cubic yard of biossoil, put a rebar in it, wrap it, put the grass over it, and now that's a future tree well that has a little more medium to grow in. But then the roots are down with the stone trench only underneath it. So we had a variation to that, to what you did. But I think we've only planted 2 trees into it. I haven't really watched to see how they're doing. But yeah, having the flexibility to do different things in different situations is a great combination.
Wayne, I think there's a question about clarifying the cost. When you were estimating 3,750, was that per day or per trench?
That was per trench. That was installation cost. Because pretty much the contractors, basically they look at this as how many can I get done in a day? What are my costs? I got to get my equipment. I got to get my laborers. I got to get my operator. How much can we, if they can get 3 trenches in a day, they're doing great. So that was 3,700 per trench. And if they can, the more they, like I said, every step you can take out of the equation, if that lets them put another step, another trench in, now they're going to be making money, and they may want to do this more frequently.
Any other questions?
I had a quick question. Is there an expected lifespan for these systems, assuming that the maintenance is
Forever.
forever?
I'm hoping. I think I've read that these are 6, 8, 10 years, but first one's 4 years old. We clean your catch basins. Has the ability to be vacuumed out if you need to. Which, by the way, if you're vacuuming out the pipe, then has anything got into the stone? I don't know. You can't vacuum out the stone. But with the high, in this case here, with these high infiltration soils, the hydrological group A, I would say you'd get a pretty long expectancy. B's, maybe not so much, but it's yet to be determined. I'm hoping to not have to replace one, but I'm retiring in 10 years, so it won't be my problem. Did I say 10? It's really 13.
I have a question. Did you run into any groundwater issues, or I don't see a depth to groundwater minimum separation on the detail?
No,
Did UNH get into that?
Obviously recommend 2 feet. And in my opinion, I don't think it matters. I think 1 foot would probably be okay, but I don't think DEP or EPA would go with that. That's why we kind of stuck at 5 feet, 6 feet. This year, we're going deeper. We're going to 6.5 feet at times. But I asked our designer to be a little careful. I kind of showed him I turned on the GIS layer, and I was able to show 2-foot contours. And gave him a quick lesson in hydrogeology and then water table rise from the river, because the river is being fed by the groundwater, that base flow. So we're trying to stay above the 7 feet for sure. But the 5 feet does that very easily. This year, we're going to try to go 6.5 feet on one, but we're in an area that's higher. So as long as you can confirm, it's hard. You look at web soil survey and all they say is greater than 80 inches. So with some thoughtful consideration, understanding the geology and the topography, I think you can go to 7 feet in certain areas. But I mean, we have half of the east end is beautiful sand, so you're not going to have a high groundwater rise like you would in the heights, where it's a till that's kind of perching that water table a little bit. So we try to stay above it by 2 feet from the nearby. We make an assumption that if we're nearby to the river, that we're 2 feet above that for groundwater, and then if we could stay 2 feet above that, we will.
Okay, so you don't do any test pits. You just make your best assumption.
Yeah, we haven't. No, this is a simple design in-house. I designed the first year. We hired a junior engineer the second year, and he came in, and the two of us, he did all the work. He turned it from my chicken scratch hand details to CAD, which looks really nice now. And he took over the whole thing this year. So it's simple. The design is simple. There's only a few elevations. There's only a few criterias. He did it himself. He's been here for a year. In the second year, he did the whole thing, put out the bid. I just kind of monitored. It's really not very difficult. If you have time in-house staff can do this easily. And we've worked with some interns from the Mystic River Watershed Association and showed them how to do pre-site selection, how to do the designs, and they have developed I don't want to say, but a cheat sheet to help as a guide for site selection and design. So it's something that process, if documented well and simple, it's been handed over now to elections in Western Medford and Winchester. So it's simple. Some towns don't have the time or the staff. So this upcoming year, our grant was for about $187,000. We're doing all the design and construction monitoring in-house. We only have 4 engineers, and Winchester is subbing it all out. They're paying $39,000 off the bat to Weston Sampson to do design. Well, no, thank you. I'd rather do the designs myself and put more in the ground than line the pockets of those large consultants, But I'm not biased at all. So if you have the staff, I got a young guy, he's eager. This is great exercise for him. Lessons learned, throw a couple on his PE registration packet. This is good stuff. It's easy. And the best part is over the course of the 4 years now, I'm making the details better. They're cleaner, they're neater. Hopefully can be transferable to other communities in the watershed or to other watersheds, you know, but importance is the soils. I think that's very important.
Wayne, I have a couple of questions. Do the observation ports have any difficulties? And do all trenches get them? And then secondly, are we the leaders in this infiltration trench approach to try to remove phosphorus, or are other parts of the country doing the same thing that we are?
I don't know. I've been patted on the back by our friends at DEP and EPA. I would say other places are doing it as well. Philadelphia, Chesapeake Bay, they all have their own little approaches. My first thought was I wanted to mimic Philadelphia, but I looked at their tree well detail, and it included a ton of excavation and precast concrete installations. And before you know it, it's like I just saw money going out down the drain. You know what I mean? No pun intended. And I tried to make this not so much that you can get everything at Home Depot, which I don't think you can, but that was my goal, to make it simpler and make it easier, so that we wouldn't have to pay the high costs. I mean, what's the cost of a 5-foot diameter concrete structure? That's, you know, plus then you got to pick it up and move it, and it adds to it. This is simpler. It doesn't require a ton of extra equipment. But yeah, other places are actually doing great things, and you know, we hope everyone will.
I have a question. I mean, I'm not an engineer, I'm not on that, I'm the educational person. But my question would be, all these pollutants, I mean, they go through the gravel, right? Before the water goes into, now, does it come a point that there's too many pollutants in these gravel that need to be, you know, cleaned or whatever? I mean, you know, over time, I would imagine there would be a lot of pollutants in the gravel, correct?
Over time, yes, but I think the stone's not treating it. So the stone is really just giving it its volume. Where the treatment's coming is where the stone and the soil interface is, and the soil is what's doing the treatment. So the soil will bind to the contaminant. The contaminant particles will bind to the soil through chemical absorption, physical absorption, and yeah, I would imagine at some point, depending on the characteristics of the phosphorus, does it settle out and bind up and become solid and make the infiltration no longer viable? And that's the expected lifespan of the trench, and we'll see. That's why the inspection ports are there. So I guess, yeah, it's technically the soil is the filter, and the filter can clog. So eventually, yeah, depending on how much is going in, and you know, the soil characteristics, you know, what are the macroscopic channels that it's following? Is it going away? Is it getting filtered in the first 2 inches? I think that's why the high infiltration soils, hydrologic group A's are so much more beneficial in this case, because they wouldn't I don't think clog up as soon or as close to the trench as maybe a till type soil, which probably it would even be worth doing.
And so this would be checked every so often, just
once a year, twice a year. We've only done once now, but it's really just, I think, checking once a year within 24 hours after a rainstorm. As long as it's dry, it's working. If we come to a point where within 24 hours after a rainstorm, we check and we're sloshing the tape measure down the bottom and you still hear the water, well, now let's wait 48 hours. And as soon as that sloshing isn't going away, then your trench is gone. It's not doing anything anymore. It's just storing in the stone, which would still work, but not as effectively.
Okay. So once the stones are in, so the top, whatever, the trench, the top part of it, that's stationary. I mean, that's not removable, right?
Right. Well,
Okay.
only if you start over again, excavate it, you could
Yeah, if you
rebuild the
start
whole
over
thing.
again,
And then
right.
you'd have to, yeah, I wouldn't recommend that in 10 or 12 years. Like you said, if the filtering layer gets clogged, then you'd have to go down and determine how much is it clogged. Is it 2 inches, is it 6 inches, is it a foot? How much do you remove? And hopefully by then they have a magic phosphorus removal pill. You just throw it in the sump and it does all the work. But I don't, that's gonna
Well,
happen.
doesn't it make sense to have something that it could be easily removed instead of just
That would be perfect,
a
yeah.
regular asphalt?
Yeah, and there's a couple things that we're considering with the UNH Center is putting in some media into the pipe that can be removed, replaced, that has a binding capacity to phosphorus. So almost like those filter cartridges, but it has to be accessible. So possibly from, who was it, the developer of the eliminator was looking into that. So imagine you have a 10-inch pipe. That's where the eliminator gets stuck in. And that first 12 inches, imagine a plug, not a cork, but a plug that allows water to flow through it, but it's made out of, carbon filter or charcoal filters or something that binds and attaches or makes the phosphorus or whatever your goal, your contaminant goal is, bind to it. And then you remove the plug. Now you've kind of captured it in the plug. You replace the plug. Or in the case of a ring garden, it's the roots, the plants uptake it, and then you replace the plants. So that's a good thing. But in this case here, it's hard to replace it without just rebuilding it again and having to excavate further.
Thank you.
Sure.
Yeah, Wayne, we'll be putting in a extremely large device, similar to what you said about the charcoal. We'll be pre and post testing how well it removes phosphorus. And whatever we come up with, the results could then be downsized to see if we could make such a thing for catch. And you would basically have them in a bag. And once we figured 2 years, every 2 years we have to go and take the bag out, probably sell it to some farmer as the best fertilizer you ever had.
Phosphorus is not allowed in the fertilizer anymore, remember? Sorry.
Oh, this goes up to Maine. Remember, that's what we.
That's
remember,
fine.
that's how
That's
that
perfect.
works.
Yeah. What town are you in, John?
Boston.
Oh, okay. Oh, you're the John. Okay. Hi.
Yeah, right. Anyway, no, so we have all these little experiments we're doing, and hopefully do a little science behind it so we can send it and share with EPA and everybody else saying this is what works and this is what doesn't. Because I think some of this stuff isn't working as great as we thought it might, but we'll find out.
Yeah, no, I'd love to team up if you have any ideas to work on something.
We'll keep you in mind, especially if you can build stuff for $3,000 because we set up the equipment. That's what it costs us for setting it up.
Well, that's because you're in Boston, that high rent district. Any other questions? Oh, sorry, Carrie.
Sorry, Wayne.
R. McGregor, you said you had a couple, but I only got one question out of you.
My first question was the observation or the ports that you would inspect annually.
Yeah. Oh yeah, they didn't answer it. We put one for every 5 trenches, which is kind of trying to cheap out a little bit. It would be great if you could put them everywhere. So we do put them everywhere when we do the green trench off of the street, but in the street, we went with a larger diameter with a cast iron like lamp hole cover over it, which is a little more expensive. So I think if you can, and your trenches are close, and we've done all our trenches in neighborhoods that are close to each other. If you can, I would say, hey, if the conditions are the same for the sand at installation, maybe use 1 for 5, which is what we did. So if one starts to fail, we're going to say, we might want to go in there and maybe do some inspections and install some more ports or double check on them. But for now, yeah, that added a good cost to the process. So we tried to keep it down. Ideally, in a financially secure world, if we had all the money, I'd put one on every single trench for sure. But we're always looking for new ideas or new tricks or something to try to do that.
Thanks.
Any last questions? All right. Well, thank you so much, Wayne. I really
It was
appreciate you.
very fun to talk. I
spending so much
apologize.
time with us.
Every time I give the presentation, I know I need to get the green infiltration trench and the tree well trench, and there's a couple more details I think that would make this a really, really more fun presentation. Some of the ones that are up there are old and they're not that very, they're not very exciting, but I'll work on it. I'll see you next year. We'll do another one.
We'll have you back so that you can
Okay. That sounds great.
increase the excitement.
All right.